that.
Well, you don't have an argument for that either. It's measured flat. It's obviously flat. Water's flat. So measured as it means it's measured as if it is flat.
Okay, so then that means what?
As flat.
So, like, if you assume
it's treated as flat. Yeah.
That's begging the question, isn't it? If you assume it's flat and then measure.
Well, if you assume it's flat and it all works as flat, then it's flat.
Oh, affirming the consequent. Affirming the consequent.
If it was a globe and you assumed it was flat and measured it as flat, you'd be fucked. You wouldn't know what you're doing.
What makes you think that?
If you're going to measure a basketball, you'd measure a basketball. You'd use spherical, some kind of technique. You wouldn't just use a ruler.
You think it's impossible to assume a sphere is flat for the sake of measurement?
Oh god, Snufkin's come in with his little crew. I was wondering, I thought that voice was familiar. Mez, Snufkin, is there only two of them?
There's only two of them.
Man of the globe, new name. What's up, guys?
I think it was a Cyclone that gave me this title.
So it's pretzel logic. Pretzel logic somehow.
I'm here for my turkey leg, as they say. No, sadly, my crew is just me and Mez these days. You know, there's no one else.
You got nothing to do. You got no globe. You got no argument against the flat Earth evidence. All you got is these twisty turvy pretzels.
You want to know?
Pretzels are making me thirsty. Pretzels are making me thirsty.
Okay.
Well, the arguments all over the place. If this,
I'm not even making it.
Yes, and therefore level is curved or something.
I'll give you an argument, Daz. If you're ready for it.
Just in denial. This is just cog this. Coping mechanism.
If Mez is the Batman of the globe, then I'm the Joker of the globe.
Are you two here as a pair?
Yeah, we're like a couple. You know.
What happens if one of the couple disappeared? What happens to the other?
Would be heartbroken.
Yeah, I would probably kill myself.
You would leave Would you leave if Mez disappeared right now?
Yes.
Okay. I won't hit enter just yet. Then
I need him here to hold my hand.
About me already? I haven't said anything.
Don't talk, Mez. It's not going to work out well for you, bro.
All right. Oh, well, I don't feel like having another conversation.
Just have to hit the enter key. So just remember this. Enter. Got my finger on it.
Tell you to say that.
I feel like you two need to make up. You know, like you got a lot in common. So
yeah, he's so much.
Yeah, he's not Batman. He's not the Joker. He's just a joke. So
yeah,
I am Batman.
Oh yeah.
Where's my turkey leg? Is there anything new on Flat Earth, or is it all the same?
Yeah, there's a clip of a guy going apeshit. You should hear it.
That's pretty funny.
Why doesn't Nathan Oakley come around anymore?
I don't know. You should ask him.
You know, me and Mez met Nathan Oakley in real life.
We did.
That's good.
Yeah. Shook his hand.
He's a lot
like a bowling pin.
Well, I met Jason Dunstall.
Who's that?
You know Jason Dunstall, JD? JD?
The only way you can top what I've done is if you meet McToon.
Gosh.
Yeah.
Act like he's somebody special.
No. Jason Dunstall's kicked the second most goals in the AFL.
Because if you go meet a flat earther, it's like just two friends hanging out. You've got to meet like the king of the globers, you know? Or if you met Neil deGrasse Tyson.
Is he which one, McToon or Neil deGrasse? Which one of those two is your king?
I feel like it would be funnier if you met, but you probably would get more out of meeting McToon.
Yeah, the highlight of the trip would be taking your shirts off in the cold and also sharing a tent.
Yeah. But what is the argument for the flat Earth? Anyone got one?
I was going to say, I think it was George Musa was talking to Fight the Flat Earth and buried him on gravity. Fight the Flat Earth was like, oh, gravity's a force, isn't it? And he's like, no, it's not. It's not a force. And Fight the Force But the flat Earth was like, oh, just whole guts fillets were argument.
Yeah, the hard-nosed Globers, after all, pick their nose and then eat their boogers. We got we got a video of that, so we got receipts.
And he doesn't even do it discreetly. Like he just full on like digs in there and then eats it. It's
kind of like what Mez is doing right now behind the camera.
True. Digging for gold.
I know.
Digging for flat Earth proof. I haven't found any.
You won't find it in your nose and then tasting whatever comes out. So that's not where you find
I have
that.
to look in my toilet. That's where usually where you tell me to look. Maybe it comes out the other end.
Unfortunately for you, the water in there is also level and flat. So
No.
no Globe Earth evidence there.
Toilet proof flat Earth. How do you know that the water in a toilet bowl is flat?
Well, you guys plunge Mez's head into it, and then he can tell you from the inside.
You guys can do bathroom play.
Yeah, if you're floating around in the toilet while it's spinning, you might be able to get some Coriolis if somebody throws a ball over top of you.
That's a cool one.
What about the moon? Have we figured out what the moon is yet?
What's the moon?
The globe? Yeah.
Ask him what the moon is. What's the moon, Mez?
It's this thing in the sky.
What
It's
else?
like a big ball of rock.
Really?
Ball of
Called the
rock.
moon.
Fascinating.
Floating rocks?
Yeah.
What makes
Anything
it
else?
stay there?
I don't
What
know.
makes it stay there?
It's up there. We all see it.
Okay, and?
The scientists tell me it's gravity, but
Yeah, which
we know
one?
it's flat. So what is?
Which scientist? Do you know anything, Mez, other than what you can see?
No, but I see the moon. Do you know what it is?
I don't think anybody here is laying claim to that, except for you trying to.
We make no claims.
How did it get there?
God
You don't know. God put the moon in the sky. Which God?
The one true God, of course.
And how did he do that?
I don't know. God magic.
God magic.
You're just a wellspring of information, aren't you, Mez?
So everything
Yeah.
does that like everything in the sky, right? That's all God magic?
It must be right. I mean, if it's not a sphere,
No, this is
the Earth's really flat, then how did those things in the sky get there?
Well, you're saying it's God magic.
Well, it's not gravity. We know that. So what is it?
No, you're saying it's God magic, yeah? Are you saying the moon
I'm not saying
formed?
anything. I'm spitballing ideas.
Because of gravity. How did it get there? Because of gravity.
Oh, we know it's not gravity. Come on. The Earth's not a ball.
Are you trying to LARP?
They've been lying to us.
What are you
They're
doing
lying
right
about
now?
gravity.
You're trying
How
to
does the
LARP.
moon stay up there?
LARPing's not going to work. Look, dude, bro, I just have to hit enter. I already got /ban member Batman of the Globe typed in the chat. Just got to hit enter. And then Snufkin's also gone, but it's been kind of quiet in here, so I haven't hit enter yet.
Okay.
So what we need to do is and post this room and say, no one join, because Mez will get banned as soon as someone else joins.
Well, we don't know that yet. We have to try that out. Let's test that theory.
Yeah. Ions, do you think the Earth is a globe?
Answer.
Anyone? Damn it, there's no one else. Right, we got an EHO, Snufkin.
Well, we are the life of the party at the end of it, I wonder, because, Creation Bear, he said that Flat Earth are doing victory laps. It doesn't feel like it, Do you feel like you're on victory laps?
We shut down SpaceX and NASA. We're doing victory laps.
Oh. Flat Earthers did that.
Yep.
Oh.
Yeah, we're doing victory laps, and the Globers are just on the sidelines, just like going, "Oh, you didn't win! You cheated."
Do any of you have like a new argument that I haven't heard before? Like anything fresh out of the oven?
Globe's been debunked.
And how did it get debunked?
We see
Curve.
it's measured flat. Gas pressure
What
requires
level?
a container.
Yeah, there's no curvature.
Other than all the curves you can see. But that's all seeking refraction.
You can see. No. You see curvature? Who said that? Your Mez.
That was me.
Oh, yeah, you see curvature, Mez?
Yeah, drop over distance.
Okay. What are you going to present?
Well, do I need to present it again? Are you going to pull a chat GPT to debunk
You got
me?
that one blurry photo to present. This same
There's
as
quite a
every
few
time.
blurry photos.
Blurry photo with no data behind it.
Yeah, exactly.
It's quite a lot of data behind it.
Because it's from a mountain, you don't have to worry about any kind of miraging or refraction. So, but then when we present anything from a mountain, that should be half a mile or a mile below the curvature. It's refraction then.
What have
Hey,
you presented at the top of a mountain?
Come on, Mez. Hey, DJ, you should talk to Ions. Look what he's posting in the chat.
Oh, Ions is it? Oh, wow.
Yeah.
Ions, can you open your mic at all? Ions? If you open your mic, Ions, I'll ban Mez. How about that? How's that for a deal?
It's a pretty good deal. I'll take that.
He'll stay silent. Keep Mez in there.
Yeah, I'm joking. I will definitely not do that. All right, he's not a globe defender.
So DJ, how did you feel about ChatGPT betraying you?
ChatGPT?
Wow, you know.
ChatGPT?
Yeah.
What about it?
About the theodolites.
Yeah, ChatGPT definitely said that theodolites should have a maximum range, and if they're used out of that range, then there can be huge problems. Right.
So when I asked it if it can measure an angle to something 93 million miles away like the sun, why did it say yes?
Oh.
I think 93 million miles is a lot longer than 500 meters.
You're not determining, because you're not trying to work out drop over distance with that, are you?
Yeah, I am. It's an angle.
No, you're not. You're just trying to find the angle to the sun, and you can do that with any optic device.
Yeah, like a theodolite.
Well, you're using the rangefinder on the theodolite, dummy.
Yeah.
Yeah.
So
how far away is the sun?
The theodolite itself is the whole device. You're talking about just a rangefinder when you're looking through that with the little reticle that's in there. That's all you're looking through.
Yeah, and I get an angle. What's the angle from?
Yeah, but you're not using the theodolite like you're saying. You're misappropriating the whole device to use it for what you think you're using. You're not. You're just looking to the rangefinder. That's all you're doing.
Okay, and I get an angle.
Yeah. So you can do that with any optic.
So what's the angle from?
So that's all you're doing.
No, I get, where do binoculars give you an angle?
Yeah, your argument from using the theodolite for anything it's not useful.
You said I can get an angle with a binocular.
Well, I mean, if you're trying to figure out like
why is it a false comparison? A theodolite gives me an angle. Binoculars don't.
Not the theodolite, the rangefinder that you're using. It's the optic.
No, I get an angle. What's the angle measured between?
What is it?
I'm asking you. What is it?
Because you're either going to be putting a tangential
reverse the
line.
burden of proof.
Yeah, well, I have to because you're already misappropriating the device.
You say I'm using the tool incorrectly. You say binoculars give me an angle. So what?
You're using the rangefinder. Are you using the whole theodolite? Are you using the whole thing? Yeah. Go ahead. Demonstrate a method how you're using the whole thing to.
So you set it up. You get horizontal, then you get your optic. You point the crosshairs at something that'll give you an angle between horizontal and whatever you point it at.
Okay, so how did you decide that the angle of the sun has anything to do with the curvature of the Earth?
I didn't. But you're saying that you can't use a theodolite to measure something beyond 500 meters.
Yeah, because you're not.
Well, how far away is the sun? Because we can measure an angle.
You're not going for linear distance, dude. You're not measuring linear distance.
We're not measuring linear distance. So what's an angle?
Yeah. Dude, are you measuring linear distance with the theodolite?
We're measuring an angle.
Yeah. Is that linear distance?
Yeah. So we can use a theodolite to measure an angle.
Yeah. Go ahead and tell me how you measure for the distance to the sun using a theodolite.
We don't need to know the distance to the sun. We just need to know if it's above 500 meters or not.
So you're not looking for linear distance, which I was correct on. You're not using the device for that.
You're not really correct about anything. How far away is the sun? Is the sun more than 500 meters away? That's like the important
detail. We don't care. We don't care. And you're not measuring.
So you think the sun could be closer than 500 meters?
See how you're like funding muting me because you don't want me to get to the crescendo.
Funding muting you?
Which you're over talking me. That's what you're doing. So you haven't measured. You're doing it again. You love to do it, don't you? So you're not measuring drop over distance using the theodolite, nor are you getting linear distance to the sun. Two things you're not doing with the theodolite, and what are you doing with it outside of that? If you're not using it for those two things, then what are you doing with it? What?
We're measuring an angle.
So what? Who cares?
Well, you care.
We don't care. No, we don't.
You seem to hinge a lot on these theodolites don't work past 500 meters.
Yeah, because you're not trying to measure linear distance, which we were correct
What's linear distance?
And you're not getting drop over distance. Either one of those things you're not doing, so we're good. Yeah, whatever else you use it for, you can eat cereal with it. We don't care.
You keep saying linear distance. What does that mean?
Yeah, you don't know what it means, obviously. If you have to ask me,
well, clearly I don't. So you keep using the term. So why do you keep saying it?
Yeah, determining the distance to something that you see in the sky.
Okay, yes, we're not determining the distance to something.
Well, then what? Yeah, that's what I said. That was my argument. Since you're not using it for those
correct.
things,
We're not determining the distance to the sun.
Yeah, or finding out the drop over distance, which you would need if there was a globe, but you don't have that either. So whatever else you use it for, we don't give a shit. Use it for whatever. Comb your hair.
We don't use a theodolite to measure distance. We use it to measure angles. Are you okay with that?
What, dude? Who cares?
Okay, so if I measure a negative angle to something that should be above me, what does that mean?
Negative angle. Dude, if you're not using it for those two things that I said you need to use it for, if you think the Earth's a globe, then you can do whatever you want and your argument is moot. Essentially.
I don't think it's moot. I think you just don't like it.
I don't care what you think, dude. The argument still stands.
You're not measuring what I think, because I think I've provided some good evidence against the flat Earth.
You didn't provide shit except for your idea of measuring angles, which it doesn't matter in this context because we're looking for drop over distance. I'm telling you, we're looking for drop over distance, or
yeah, and I measured drop over distance.
If you're measuring distance to the sun, then sure, try to find that out.
No, I didn't say we're measuring distance to the sun.
Good. So therefore, it's not used for those two things.
You're straw manning me.
It doesn't matter.
I'm determining the consequence.
It's not used for those two things, so then I don't care what you use it for. Yeah, use it for whatever you want. Dig a hole.
We can measure an angle with it. We can measure an angle.
Yeah, so what, dude? Go tell
if something's above me.
We don't,
if something's above me, do I measure a positive or a negative angle to it?
Nobody cares. This form only cares if you're going to use it for drop over distance.
I think you do care, Mickey.
No, we don't. We don't. No, I don't care about you liking it or not. Bro. This has nothing to do with that.
Of course you do. This is your worldview.
Yeah, your worldview? Yeah, well, yours is broken. You didn't find any drop over distance? Yeah.
Yeah,
what? Yeah, you live in a fantasy land. Of course, you think just measuring angles is good.
No, real world.
Great. So what? Who cares? Nobody cares. Fucking, you think that's you measured an angle? Whoop-de-doo. You want a cookie? Like, it's not measuring drop over distance. You don't know if the Earth's a globe or not. I would love a cookie. So we're all good over here.
I measured it.
Measured what? An angle? That's not drop over distance, dumbass.
Yeah, it is.
Yeah, show me. Show the methodology to measure drop over distance with the theodolite, bro.
So if I know the height of two things,
the theodolite, do you?
We can predict what the height should be. Do you agree? If we know the height of two things, we can predict what the angle from one to the other should be on flat Earth, right? Or
flat Earth? What do you mean flat Earth? I thought you're determining whether it's a globe or not.
So we make a prediction. We're doing a falsification. We're doing the modus ponens, or was it Tollens? Whichever one.
A modus ponens?
One.
Are you trying to figure out drop over distance?
Not this, therefore not flat.
Yes or no? Like, what's this all this word semantics? Are you trying to measure drop over distance or not?
Yeah.
Oh, then show them.
Okay. Well, hold on. How do you like this argument?
Show the method how you measure drop over distance.
We should always be able to measure a positive angle from horizontal to something above us.
It ain't about flat Earth. It is not about flat Earth.
We do not always measure an angle to something.
Okay, here we go.
A positive angle to something that is above us. Therefore, the Earth cannot be flat.
Yeah, you're not going to affirm that the Earth is a globe, right? You just run away from that. Put your track shoes on and run away from the claim measuring drop over distance with the theodolite. Go ahead, do that.
Through falsifying flat.
That falsifying flat. You haven't affirmed the globe. So that's your whole...
Why do I need to affirm the globe?
Because that's your claim. You think you live on a ball, dude. You think you live on a ball, which would be measurable if it was, and it's not, because you haven't proved it. You still haven't. You're dancing around the topic just to avoid the fact that you can't.
I think you're dancing around the drop over distance measurement.
Yeah, you didn't measure that. Exactly. That's my point. Thank you.
But it's measured. We measure a negative angle to something that should be 3,000 feet higher.
Here we go with the negative angle. Dude, you didn't measure drop over distance. What would be the distance between...
So what is a negative angle then?
Yeah,
if not drop over distance.
Yeah, figure this out, man. If you're going to have a tangential line and the Earth's supposedly curving away from the observer, then how far would it have to be to curve away till you can't see anything anymore? Like, let's say where ships disappear from the bottom up. Where does that happen?
Now you're doing we see too far.
No, I'm saying that you haven't provided evidence that what people see is the geometric curve of the Earth. You haven't done that. You're just dancing around the topic, talking about
I don't think I'm dancing around it. We've measured an angle for something that should be above us. But it seems to be below us.
Yeah, we're trying to figure out the ground curving.
How's that possible if the Earth is flat?
Not something above us?
What, it's flat?
We're not looking at the sky, the sun, the stars.
We're not looking at the sky. We're looking at the peaks and mountains. You're straw man.
Yeah, peaks and mountains. Really. So then, how much drop over distance would there be from an observer to, let's say, where the mountain is?
So based on these two mountains, I'm thinking of about 3,000 feet of drop.
Yeah. Well, go ahead and show us how you work that out. Go ahead. Now we're getting somewhere. Show us how you work that out with a drop over distance that's been measured.
So you figure out where you are. You figure out your elevation. You figure out where the mountain is that you're looking at.
Yeah. How do you figure out? Hold on.
And then you can predict.
No, you're skipping some steps. Hold up. No.
If I'm at 3,000 feet and the peak of the mountain is at 6,000 feet.
You're not just going to barrel through me, dude.
I should measure a positive angle from horizontal to that mountain.
I'm going to stop you, Mez.
But I don't measure a positive angle to that mountain.
I'm going to stop you, Mez.
So the Earth cannot be flat.
All right, so he's just going to barrel through and just say whatever he wants?
No, you asked me to explain it, so I explained it.
Yeah, but you didn't do it correctly. If you're measuring elevation, how did you
explain how I didn't do it correctly?
How did you? Yeah, I'm telling you, dude. You didn't measure it. How did you measure elevation?
With a theodolite again.
Yeah. How do you derive elevation from what? What is it referencing?
Horizontal.
Yeah, I know that. So if you're measuring horizontal, which is flat and it's not curving,
no, you're not measuring horizontal. You're measuring from horizontal.
Yeah, so it's the same deal, dude. You're measuring from the horizontal.
You don't measure horizontal, you measure from horizontal.
The horizontal plane of the Earth is what you're measuring from. That's zero,
That's a reification fallacy.
No, it's not a reification. You just said it. You're just saying it yourself.
You are reifacing. Well, the concept of horizontal exists, therefore the Earth must be flat.
Concept? Well, horizontals don't exist on the surface of the Earth. You're saying the Earth is not displaying itself as horizontal? Is that what you're saying?
No, the Earth does not display itself as horizontal.
Yeah,
if it did, then we should always be able to measure a positive angle from horizontal to something that is of a higher elevation.
What is mean sea level? What is mean sea level then?
What is mean sea level?
Yeah, what is it?
That is, well, the height of the sea.
Yeah, from what?
From itself.
Hello? No, it's not from yourself, dude. Come on, Mez.
Sea level is sea level. That's your baseline.
No, yeah, of course it's our baseline, but where is it derived from?
The sea.
I know that. You're not giving me the full description of what it is.
What are you looking for?
Come on, have your buddy help you out, or get ChatGPT to chime in on this.
Shall I do a DJ? Shall I ask ChatGPT?
Do it.
ChatGPT. What? Oh. What pop up?
What is mean sea level?
What is sea level? Let's ask it.
Mean sea level.
Oh, what is mean sea level? Okay.
And just by the way, right? I asked ChatGPT to find me the manual for this specific theodolite that you said was used in this observation.
You asked ChatGPT to find you a manual. Are you retarded?
Yes. Yeah. To find the manual. Well, it's just basically a search engine, yeah?
No.
Right.
It's a language model.
Yeah, but it searches the internet, dude. Right. So the theodolite that you mentioned has a recommended range limit of 300 to 500 meters.
Why does it have a recommended range limit of 300 to 500 meters?
Because beyond that, there are things that you need to take into consideration that can make the angle, right, in the distance way off.
So why don't those matter below 500 meters?
It's inaccurate if you use it beyond its recommended range limit. That's what I used ChatGPT for.
Why don't those matter below 500 meters? What are you using for with below 500 meters?
Surveying, dude.
Surveying, right. Now, are we doing surveying?
You're using it to look at a mountain 90 kilometers away or 90 miles away or something like that and think you're getting an accurate reading.
Are we doing surveying when we do that?
Yeah. Yeah, because he's using it outside of its working parameters, and he keeps doing it thinking using Jesse Pathelite's argument is going to help him determine whether or not he can think of the Earth as a globe. And it's not doing that because, like, we've been telling him for how long has this been, DJ? I'm saying it's been at least a year. We've been telling Mez this. He still uses Jesse Pathelite's argument, and we keep telling him you can't use that theodolite. What kind of theodolite is it? What model number? And then you look at the model number, you look up the specifics. Of course, every professional that uses it for surveying. Yeah, really. So
yeah, but we're not doing surveying for construction here, are we?
So then why are you using it? You can't use it outside of its working context. You can't just say,
we are using it outside of its working context.
As a mallet, like to hammer down things. Like you got to use it for what it's designed for. It's meant to be used for something. And if it has a model number,
it's designed for measuring angles, and it can measure angles.
Yeah, it's very specific. So it has its working parameters.
It's not very specific.
That you want to take it outside.
Its working parameter is infinite.
Oh, we can
I've showed you the model before, AV. It says it has an infinite
75 miles away, dude. Like you're interrupting.
I've showed you.
Yeah, you just like over talking
when you get time. When he stops running his mouth, I'd like to say something.
Yeah, but like he wants to interrupt because using Jesse Pathelite's argument, he thinks Jesse Pathelite has been known to be a liar anyway. He's fudging the numbers that he puts down on his spreadsheet. We've already called him out on it numerous times. That's number one. That's like right off the rip. And on top of that, we've asked him for the model numbers of all the things that he's using on the theodolites. And they're all outside of the working parameters for the distance that he wants to use them for to see these mountains. Like we've called him out many times. And this is what Mez is trying to champion and carry this point forward. It's dead. You can't use it for this.
No, it hasn't. Maybe you're wrong. I've showed you the manual. It has a range.
I would tell Jesse, I'd say, look, you can't use the planter peanut guy's monocle to freaking do long range freaking like sniping. That's what it's like. It's like using.
Well, I mean, specifically wrong. Specifically in this context. Specifically in this context, surveyors use specific model of theodolites and total stations to actually get the job done, whatever job it is, specifically, right? And multi-million-dollar projects depend on people's accuracy, so they're going to use it for their specific intended use. Now, this guy,
are we making a multi-million-dollar project?
Shut up. Just be quiet. All right,
yes,
so like him and Jesse.
So maybe we don't need to be that accurate.
Thank you.
So, maybe we need to be that accurate. That was his last statement.
Yeah, I'm saying though, DJ, like we've been like getting these guys on this point. It's easy because they are not supposed to be doing what they think they can do with them. So it's easy for us to debunk them right off the rip because they're trying to use these devices to prove globe, and it's not doing that for them. Yeah, I mean they seem to think it's a winner, but it's like, dude, you don't have an argument. Professionals would laugh you off a job site if you think you could see mountains at 75 miles away, bro, and then get accuracy out of it. Dude, you're clowns, bro. In this realm that we're in right here, you guys are clowns. Yeah, come up with a better argument than this. And we've been saving it for the better part of a year, man. Like, drop this argument. Jesse Pathelite is incorrect. Well, yeah.
It's not actually that good beyond like 200 meters. You know, when surveyors actually use theodolites, they actually move it down. Have you seen them move it from one place down the road to the end of the street? So they start like, a property, then they move it 100 meters down, then they move it 100 meters down again because they don't actually use it to survey the whole 500 meter diameter. Like, these things are not as accurate as you think. If you want to use it to measure from a 500 meter distance, you're going to fail initially. You're telling me you can measure how long with theodolite?
It's like 90 miles, he's claiming, something like that.
Yep.
Yeah, all right, buddy. So the surveyors I work with have $40,000-$50,000 theodolites. Like, we're not talking your $300 online one you can buy, and they're not using it to measure more than 200-300 meters while they move it at 100 meter increments, right? These things are not used.
You guys keep bringing up people using these for construction. We're not doing construction.
They're not construction.
The peak of an angle, the peak of a mountain.
Like, surveyors don't use them for construction. They use them to measure and give you, they measure services, locations, and give you dimensions, right? They're not used for actual building.
Okay, so I posted a picture in there, and you're going to tell me how
he's very really quick to have this conversation, Oliver. He has been for a better part of a year, bro.
So if I use a theodolite,
him and Jesse Pat the light, they
that has an inaccuracy of 20 arc seconds. What's the inaccuracy?
So now you're getting to the specifics. Oh, how is it convenient now that you want to talk about specifics when you don't
talk
care
about the specifics?
No. You don't care about them when it concerns long distances, dude. This is your problem.
No, I do. I do care about it.
It can measure infinite distances. That's what you always say.
No, it doesn't measure infinite distances. It can measure an angle between something.
Yeah, you want to talk about architecture right now.
So hold on.
Maybe, do you think theodolites measure distance?
Hold on, Batman. Have you actually taken the measurements yourself?
No, this is Jesse Patholite.
Okay, so can you post these measurements and can you verify them?
Can I verify? I mean, I can post you his data. I can post you a screenshot from the video.
Is that the old man that a couple months ago we talked to that said this is my theodolite? It was like the eBay one.
I want to say it was. No, he's got like a really high pitched nasally voice. Jesse Patholite does.
Is he the one that we spoke to a while back that like we found on eBay in the manual and
yes, that's him. That's him.
He said he got it off eBay. Yep, some shitty old Nikon theodolite.
Well, no, that's the same argument, Oliver, since back then. This guy's carrying. Mez thinks that he thinks this is solid gold, man. He thinks this is the winner right here.
Yeah,
you know that guy bought a budgie theodolite. He bought a budgie theodolite, which is like $600.
Why are you assuming
it's a budgie because we looked at it. It's not an officially represented brand. It wasn't a good theodolite either.
Yep, and if these things aren't calibrated regularly, right, they can be off by magnitudes, especially over longer distances.
By magnitudes?
Now, by magnitudes, right? And also, any lens, right, could be any lens with a focus, right? If you're trying to focus it, you can just set it to infinity, right? Any shitty
so we can focus on something an infinite distance away.
Yeah, but you're not going to be able to say what you're looking at is accurately is in its actual position because we have all sorts of different things that need to be taken into consideration, which you didn't take into consideration. No, I'm not claim stacking. I'm giving you.
Well, the theodolite's broken, but you can't measure the angle. But it's too far away. But there's other things. Run away, hide from the angle. It's too scary.
Yeah, you're just being right now.
That when this guy came on here a while back, Batman, he didn't know the model number and I had to look at it. Then when we looked it up together, we asked him, "Did it come with a manual?" He's like, "No, it didn't come with a manual." So we looked it up together and we're reading through the manual. And he was surprised the whole time. He's like, "I think in the manual the first thing says this theodolite must be calibrated." And we asked him, "Hey, have you ever calibrated things?" Like, "No, it didn't come with a manual." I think you're fighting a dead horse here, bro.
I don't think I'm fighting a dead horse, and that's not the same.
Absolutely are.
But yeah, I've looked up the manual. It says it has a focusing range of 0.5 meters to infinite.
What's the model number?
120F has a angle measurement accuracy of 20 arc seconds. So 20 arc seconds is 74 miles.
What distance?
Is about 34 feet.
Dude,
I don't think if we add 34 feet onto this measurement,
it's different when you're reading the accuracy thing.
Substantial drop over distance.
Mez, stop talking over me, dude. Seriously.
You're trying to talk over me whilst I'm explaining this manual. So, shush. So we have an infinite distance, which this theodolite can measure to. It has an accuracy of 20 arc seconds.
Yeah, it's not going to work out like that for you, dude. Right, so yeah, we can hear you now. One second, Radwin. Let me just say this one thing. Right, so we looked up the manual. Just because you can focus it to infinite, right? That doesn't mean that the accuracy range is able to be included in that setting to infinite. Okay, so it has an accuracy within, I think, 300 to 500 meters maximum. Anything beyond that, right, it's not accurate. Right, that's its maximum usage range. Okay, that just because you can set the focus to infinite, which you can do on just about any camera, right? That doesn't mean that something that you're looking at, the angle is accurate. You don't use that for surveying, right? The distance. Go ahead, Radwin.
I posted this picture 3 times now, and I want him to tell me how you see that distance with that time lapse using a theodolite, and you know you're looking at the right thing.
He plugged his ears, Radwin, like a child.
He's muted, so he's not. This is just a dead. I'm not getting anywhere. Somebody needs to bring that up to him, since he.
I was going to when you posted that earlier. That's actually a great example, man. You couldn't use at any point during that day to get an accurate measurement with a theodolite to an angle.
That's every day, everywhere on Earth.
Yeah, exactly. So, Batman of the Globe, did you hear that?
No, did you see? Mic stopped working for some reason. I don't know.
Okay, that's a shame. Okay, can you see what Dr. PSI posted?
It's the
time lapse. Right. Yeah. So you couldn't use a still shot, right, and get an accurate angle measurement to any object that you're looking at, right, on that island.
Why?
Well, obviously, there's constant miraging effects taking place throughout the day.
How do you know there's constant miraging effects in the thing that I?
Because you can see them in the time lapse. It's obvious.
We're not talking about that. We're talking about the thing that I posted.
It's
right. So it's this exactly.
Do you see any warping? I don't.
It's a still shot.
Any shimmering, miraging.
It's a still shot. Where's the video? Do you have a video?
Yeah, if you want to see the video, I can post that as well.
I'll post it.
So nobody's ever had the video.
I don't know why he doesn't drop this argument. I think it would be better for him to find a different argument than this one.
It's a great argument. You haven't been able to rebut it.
Flogging a dead horse, dude. Like, that's all you're doing.
So if I showed you a similar observation, what if I showed you a similar observation? Yeah, what if I showed you a similar observation, right, from altitude, showing something that is visible that should be way below the curvature of the Earth? Right? Then what are you going to say? That you just
angle measurements.
You don't have an angle measurement, dude.
We have an. Why would you say something that is so obviously not true? Of course, we have an angle measurement. He took a theodolite there. He said he pointed at the mountain, and it said 0.27 degrees.
Yeah. So if something should be a certain distance below the curvature of the Earth, right, and we can see it above the horizon,
yeah, you just got we see too far. You don't have any measurements.
Is that not an angle that doesn't work for the globe?
No, you don't have a measurement. You've got I see too far sometimes.
What do they tell us that when the sun has already set? Okay, so when we can see the sun on the horizon, they say on the globe side, right? They say it's the people that support the globe.
Who?
The mainstream. Okay,
the mainstream. Oh, the mainstream said it.
Well, you can look it up. Do you want links? Do you want some links to some sources?
Names. You said they say. Who's they? What organization pulled that out?
All right, I can find you some. Okay, what am I claiming right now? What am I claiming?
I don't know. You just said they say.
You don't even know what I'm talking about, do you?
No, you brought up they. Who's they?
You don't, what do you think I'm trying to say right now?
I don't know. Spit it out. Come on. They say. Well, who's they?
Yes, you didn't even listen to what I was saying, right?
You just listening. You said they say.
Start spiraling.
First, who's they? I'm not spiraling.
He's not really one for conversation, DJ.
Yeah, this is why you get mad.
You pull out all these claims. They say this. We've got that. Yeah. We see too far.
According to the mainstream, when you see the sun on the horizon, it's already set, right? And it's because of refraction. Really, the sun is already set, but you're seeing it. Yeah, you don't know about that claim?
I know. Are you claiming that?
No, I'm not claiming that.
Okay. That's why I bring it up.
Because the mainstream claims, but that doesn't apply for anything else. So you're looking horizontally through the density of the density of the atmo, yeah?
The atmosphere.
Call it whatever you want. I called it atmo. You want to call it the wrong thing? That's fine. Yeah, anyway, who cares about that?
I think the mainstream calls it the atmosphere.
Yeah, I'm not the mainstream.
Oh.
So do you think that when you see the sun sitting right on the horizon, right, it's actually already set or not?
I think I have a measurement that shows drop over distance, and you're running away from it.
No. You couldn't answer my question, could you? Because what it does, if you say yes to that,
I didn't make a claim about this one.
You want to run away from this now, because if you say yes to that, then it debunks your observation.
I'm not saying anything about it. I don't need to say anything.
You can't, because it debunks your observation, doesn't it?
Nothing about. No, it doesn't.
Why can't you answer my question? Then you're running away from my question. If you see the sun,
I'm sticking to the evidence that I provided, and that you've been unable to rebut.
You don't have. You still haven't posted the video that you said you were going to post, and you haven't.
Right. I'd like to apologize.
Posted, right? Haven't accounted. You haven't accounted for the potential atmospheric conditions.
Atmo conditions. No wobbling, no miraging, no wobbling.
You haven't accounted for them.
Nothing going on.
Dude, that's over.
DJ was posting screenshots from another video. That was when refraction affects that, because you're an idiot.
Just ban him. Just get rid of him. Just get rid of him, man. He's useless. This is all the globe has. Somebody who interrupts and doesn't allow for conversation to happen. If he was right, he wouldn't need to be interrupting like the way he does. He's got a need for it, so fuck this.
Is most people in here flat earthers?
Most,
oh my god. Dude, can you present any evidence for the Earth being a globe, Fib?
It's a no. Yeah, all people are flat earthers, by the way.
That was in this call. Every single person in here is a flat earther.
Yeah, including you.
Okay, I guess my first question is, like when you're on northern hemisphere. Oh well, wait a second. That's no. Let's say you're in like one part of the Earth. Let's say part of the Earth instead of assuming globe, right? And the moon is like upside up, and then you'll see images, and it's upside down.
Curve on the Earth, but you want to talk about the moon.
The moon, yeah.
The Earth.
Because the explanation, if it's a globe, it's pretty simple. Like the top side of the.
Not a globe.
Why you don't find out why these people are flat earthers?
Oh, here we go. Real time. I'll see you guys later.
Why do you keep saying globe over and over?
Yeah, Fib. Look, man. If you have a 9 right on your ceiling, and you look at it from one side of the room, it looks like a 9, right? And then if you walk over to the other side of the room and you look up at the 9, right, it's a 6. Now, so you see different faces of the moon, but everyone sees the same face of the moon.
So that's true. So then let me ask you another question. Assuming it's on the ceiling, is it sort of assuming it's like statically above me? So how does the moon sort of fall below the horizon?
That doesn't make any sense. Statically above you?
Like with the room experiment, it would like a 9 on the ceiling is like static, like relative, right?
Yeah, I know, but like it's what his demonstration was that you can think about the floor and it being flat and seeing this image of the 6 and the 9 being opposite sides of the room, both on a flat floor. So he's trying to demonstrate to you that this can occur on a surface that's flat. You don't have to think of the Earth as a globe for this optical phenomenon.
No. Yeah, I already concede that point. I'm not doubling down on that. So now I'm adding a new feature into this paradigm, right? So now we've acknowledged that we can, assuming a static 9 on a flat Euclidean plane, we could see different perspectives. So now, when the moon falls in the horizon, right, it rises up. How does that affect our perception of if it's up or down?
No one gives a shit.
For example, if it falls really far into the east or the west,
and how surface react when that's happening?
Wait, one more time.
What is going on with the surface? What is going on with the surface of the Earth where that's happening with the moon? That's what you're explaining.
It has nothing to do, Fib, with the condition of the surface. So it's a moot point to bring up. So you have to concentrate whether or not the surface is actually curving. So I assume that's what you think the Earth is, right? A globe?
Yeah, like sort of like a sphere globe. But I think there was a very precise.
Right. So if you think that's the case, what evidence do you have, instead of looking up, do you have on the surface that determines that the Earth is an actual sphere? We're not looking up at the sky anymore. I want you to focus, right? Focus on how anybody in history, whether in academia or not, has determined that the surface is curving.
Is this shifting the burden of proof? I haven't actually.
No, this isn't shifting the burden, sir. What this is, listen, Fib, this is identifying whether you have the knowledge to actually back up the claim if the Earth is a globe. Now, you have to do this, sir.
That's just an ad hominem.
It's not an ad hominem. I'm asking for you to identify that. Is there anybody that's ever measured the surface? Not an ad hominem. Can you do it?
So I mentioned a sort of like anomaly to the scene 9 on the screen.
We're not talking about that. Don't run away from
I'm talking about it. I'm the one proposing it.
Yeah, it doesn't equal whether the surface is going to be curving or not. So whether or not, it's like you saying, I really want to talk about trains right now. It doesn't matter. That's not.
What you're arguing it's the red herring fallacy, right? That's what you're arguing. Your argument is a fallacy because you fail to see how it's relevant to the Earth being.
Listen, here's a skinny. Let's get right down to it. Can you provide evidence that the surface is curving as it would be if the Earth is a sphere? Yes or no?
I don't have hard evidence, but I want to hear your solution to the anomaly I was about to describe.
Okay, well, that's a problem. If you don't have hard evidence, sir, that's the elephant in the room you're not addressing. You want to skip past that. It's called whistling past the graveyard.
Here's the issue, though. I don't think flat earthers have hard evidence either.
Wait a minute. Okay, we can talk about that. But if you say you don't have hard evidence...
If I propose...
We'll address that. Hold on, Fib. We can address that. Let's just relax. We'll address that. If you want hard evidence for flat Earth, we'll give it to you. If you say there's none for globe, that's fine. We've got past that. You don't have hard evidence. You said so. You're the one that said it. You said there is no hard evidence for the globe.
Is my mic working again? Oh, that was weird. It cut out.
Yeah.
No, that's a straw man. I didn't say there was no evidence for globe. I said I don't have hard evidence for the globe. That's different.
Well, then where are we going to find evidence then, if it's not from you?
So If this guy interrupts me again, dude, I don't even want to listen to him because he's
what?
Look, man, I keep trying to explain it. You keep interrupting me before I even make my critical point, arguing red herring. Like, do you want me to make my point, or do you just want to like censor me? Because if you want to,
are you able to? Are you able to?
I am able to get to my point. Yeah.
Well, then let's go. Get to your point.
Right. So my point is that the moon moving through the sky, despite you saying in the same place on Earth, is along with the seeing it in the same orientation, right, upwards or downwards, is trivially explained if it's a globe, right? Just which part of the hemisphere you're in. And so my question is, in a flat Earth paradigm, how can it fall below the horizon? That's my question.
If it's falling below the horizon, angle. When you see something in the sky, it has to do with angles, right? So you're seeing something at, like, let's say above your head, it'd be 90 degree. As it moves towards the horizon, it's at a different angle. Would you agree with that or not?
Yeah. Like assuming 90 degrees perpendicular to the plane of the floor you're sitting on.
That's fine. That's fine. Yeah, that's fine. Can this happen on a flat floor?
It can happen on a flat floor, but it wouldn't be able to go below the horizon. It would just go asymptotically towards the horizon.
Yeah, what you're witnessing, though, is a convergence at the eye line on the horizon to the vanishing point. So you can only see things so far in front of you. So things are converging to your eye line. So that's how that works.
Well, I actually just didn't understand that.
Well, I mean, if you see something, think about it, right? If you look down a long corridor, it looks like the ceiling and the floor is converging at a point off in the distance. All it is perspective. That's how your eyes see the world around you. Everything's converging and getting smaller as it moves away from you. This is just optics, dude. Just understanding how your vision
works. What you're asserting is that the moon is just asymptotically approaching the horizon, but it's not necessarily going below the horizon, right?
Yeah, it's just moving towards the horizon, yeah. That's all it's doing.
Wait, I'm looking at the GIF in the chat.
So we covered that. That's it. That's it for that point. That's all that's happening. Now, in no way does that prove that the Earth is of any geometric consequence. So you can't pull out a globe from that. Because you admitted yourself this can happen on a flat floor.
No, I haven't conceded yet. I'm just thinking.
No, I'm saying at best for you, this would be inconclusive. At best.
You're putting words in my mouth. I haven't conceded that point yet. I've conceded the point.
Listen,
about the 9 on the ceiling.
You said that this could happen on a flat floor, right?
Right, but then I would, in order to indoctrinate that into a paradigm, I would have to also reassert that that's what's happening, and I would also have to reassert that it doesn't go below the horizon. So then I would have to find some experimental tests.
No. But you don't know. You don't know that it's going below the horizon, do you? If I was to ask you plainly, can you tell me if you see the sun going below the horizon? How would you be able to prove that? Think about it.
So yeah, I don't have so right now I have anecdotal evidence from just like watching sunsets, but it's easy to argue that my anecdotal evidence is flawed, right? Because I'm asking. I know. I would have to read how to confirm or deny that experience. Right now in the chat.
What I'm asking you, dude, Fib. What I'm asking is, how can you determine that it's going below the horizon? How did you determine that?
Well, you have to realize I just determined it from what I remember. But that's why I'm saying I want to rethink about it. Like re-look at it.
You should think about it, right? You should think about it because what you see is just perspective. Everything's converging to the eye line. So you see things moving across the sky.
That's the conclusion. I want to verify the premises that lead to that conclusion, which right now I don't have a good stance on either if the premises are true or not right now. But the logic is valid. Your logic is valid. I'm not against that.
All right. Well, I mean, we got more to back that up. So if we're going to say that the not only demonstration of the surface of the Earth conditionally would be a horizontal plane, we can back it up with physics, right? We can show you that the physics of water is such that you would look in physics to describe the surface of water in large quantities, right? Like as in a large body of water, it displays no convexity and such that it would follow any curvature. So water on its surface is flat and it's planar. So we can derive from physics the understanding of water, the mechanics of water, which means that if we know that water is flat, and of course, if they're telling you that there's 70% of the Earth covered in water, well, there's a lot of flat water to be covered on the surface, which in turn would equal that the surface is not curved, but yes, indeed, it's flat. According to physics, of course. Water is the great demonstrator that the Earth is flat, or a horizontal plane. And that's derived from physics. It's not derived from just me saying so. It's the mechanics of water. It's called hydrostatic equilibrium. You can look it up if you'd like. Something to think about. I gotta get going. Somebody else can pick this up.
So Fib, we're not claiming certain things that you think we might be claiming. right? So I don't know if you think about flat Earth as like a disk in space, and that's what flat Earthers think that the Earth is.
I'm not. I'm actually not. I don't know too deeply. I see a lot of different perspectives.
We're just using Professor
It's sort of like the false dilemma.
Professor Dave's thing, right?
Basically, no, I'm not. That's all.
Yes. So we're not claiming crazy things here, right? We're just testing the globe, right, to see if it matches reality. When they give us the mathematics, they say the Earth is a globe. It has a radius of 3,959 miles. Right. Therefore, in reality, if you go to a 10-mile body of water, for example, it has to curve away at a certain distance. Right. And we can go out and test that 10-mile body of water and see if the 66 foot of curvature that must be over that 10 miles is actually there. Right. And when we go out and we actually test the Earth, we can't find any curvature. And it's not just 10-mile bodies of water. Right. It's 20 miles, 30 miles, 40 miles. We've got all sorts of different, like a huge accumulation of observations and laser tests and different types of tests that we've done on the Earth. We can't find any curvature. Right, and we can't find any from the globe side either. So we're not making crazy claims. Right, we all experience the Earth as flat. So do you. Right, you've never seen any curvature. I've never seen any curvature. Right, but they say, like, obviously that's not proof that the Earth's flat, but that's the starting point, right? That's the axiom that we all experience in reality. Now, we've been taught from a young age that it's a globe and it's this particular size, and we're looking for evidence of that. That's all. You there?
Yeah, I'm just listening.
Yeah, so we have high definition observations we can show you, right? For example, over a 20-mile lake that's completely still, crystal clear conditions. Okay, so the guy sets his camera up just above the surface of the water, and he can zoom in and see the shoreline on the other side of the lake. Now, if the Earth was a globe, you can do the math based off the radius value that they tell us, and there should be 300 foot approximately of curvature over that distance. Right, from the observation height of the camera, there should be a horizon at a certain distance, which is like less than 3 miles. Everything beyond that 3 miles should be hidden behind the horizon. But over the 20-mile lake, there's no curvature. You can see the shoreline. There's no horizon. It's just completely flat, still water. Right? It's so still and nice conditions that it forms a perfect mirror reflection on the top of the lake, where you can see the mountains in the background as a perfect mirror reflection, right? So it's called a specular reflection. So to have that perfect reflection, right, you need to have a flat surface like a mirror. Otherwise, you're going to get like a warped reflection. So it's an accumulation of these long-distance observations and a whole bunch of other arguments that takes a long time to go over. Right, that led us to this conclusion that the Earth can't possibly be a globe, especially a globe the size that they tell us. So, not trying to convince you of anything, just showing you some information you might not have seen before, that's all. And it's not crazy claims. We're not making any crazy claims whatsoever. And any claim we do make, we can back it up.
I haven't called y'all crazy.
No, I know you haven't. You've been hearing good faith. You know, we get a lot of angry people coming through here, but you've been cool. I said that in the side chat before. I was like, yeah, this guy seems alright. He's actually engaging, like, you know, in good faith. So yeah, I appreciate that. Thank you.
Dude, that one image of like the fucking, what is this, like some like saltwater lake? It's the third from the bottom right now. That's so good.
Yeah, I see it. Bolivian salt flats. It's a huge area.
4,000 miles squared.
So here's an idea, right? Let's assert that like it's flat, like a Euclidean flat, and we have like, you know, our lens, like our eyes or one of these cameras that just warp the perspective the way we have it. And then let's take the number that they are asserting is the radius of the globe, right? Like we're asserting it's flat, we're taking their radius though, and then we want to warp and sort of pin out how far would you have to see that horizon. That's what I would want to know.
He's talking about how eyes can only see 3.5 miles, and that's how you actually can fit the globe with your eyesight.
Sort of. I don't know. I just wanted to.
So you're saying that? Okay. So look, when I was at school, they taught me that if you're 6 foot tall and you're standing at the water, when you look out, the horizon has to be at 3 miles away, right, on the globe Earth. Right. That's what they taught me at school. That's what the mathematics says when you punch it into like an Earth curve calculator or anything like that. So we can go out and test that. And when we do, we can see magnitudes further. It's not just we can see 10% further, 20% further. We can see like thousands of percent further than you would be able to see if the Earth's a globe. Right? And that's what I'm talking about. We got countless amount of high definition observations, right, where they're taking everything into account, right? The height of the observer. They got confirm distances, what you can see in the distance is 10, 20 miles away, whatever, right? Confirming the distances, confirming the height of the observer, right? And then you can do the math. It's simple math, right? To work out how far away the horizon should be. And we can't find anything. Like, we've been doing this for 10 plus years, right? We've not had one person come in here and show us consistent observations or any observations showing that that the Earth matches up with the mathematics that they give us.
They failed basic repeatability or reproducibility.
Well, they failed even step one, right? Even something to reproduce, right? You would need something. You'd say, all right, here's an observation that matches up with the globe.
Step one is repeatability, like being able to do it themselves.
Step one's having something to repeat in the first place, right? So if you go out and test the Earth and the horizon should be at 3 miles from a 6-foot observation height, and it's consistently not at 3 miles, right? It's consistently magnitudes further than 3 miles, right? Then you don't have anything to repeat to begin with.
Well, there's also one thing I would like to stack onto this, and I'm posting a video for you here. I would just save that and look at it later. The problem is, back in the day when they invented the globe, they didn't have any strong optics, so weren't able to see far beyond the claimed Earth curve. The human eye has a resolution limit, which is 1.22, and the way we calculate the distance to the horizon is using that 1.22 number. So we can use the diffraction limit of the human eye to get the same distance to the horizon, which would result in the same, if we assume the horizon is the leading edge of a ball, we get the same size globe from just the human eye. But now we have optics that can allow us to see much further, 10 times further than we should be able to see on the globe, so that destroys the globe. And then we also have optics that are much smaller than the human eye, and then we start to see small RC boats and other things disappear over known flat surfaces at what appears to be a horizon line, but there shouldn't be any Earth curve causing any of that, so we kind of already know that it's just the optics.
Am I still connected? Oh, yeah.
Yeah, 1.22. 1.22 times the square root of the observer's height in feet, and that will give you the distance to the horizon.
Yeah, I don't know a lot about lenses.
You don't have to. Yeah, you don't have to know a lot about lenses. I mean, I know a fair bit about lenses because I used to play.
Oh, that's what I'm saying. I know Jack.
Yeah,
all of my education was Newtonian, really trigonometry, geometry. I never did.
Well, think about this, right? Just say there's a long hallway and it curves away in the distance, right? And your friend walks down the hallway and you're watching him and he disappears off around the hallway, right? It doesn't matter what lens you're filming him with. He's still going to walk around the corner and you're not going to be able to see him anymore because there's a physical obstruction blocking him, right? So this is the same thing, right? So according to the geometry of the globe, when something goes off into the distance, it should disappear behind the curvature of the Earth. Now we can work out the exact distance it should start to disappear based off the height of the observer, right? And this is based off the size of the Earth that they tell us. You know what I mean?
Let's see if he knows what a triangle is. Okay, so look, this could be wrong. Just off the top of my head, I would think 3 sides, sum of the angles sum up to 180. That'd be my first thought. There's also has to be 3 vertices, right? The corners. I would think.
Yeah. So look at that picture I posted underneath that. I was just saying it to DJ.
My original guess would be B and D can't be because D doesn't have 3 vertices. D doesn't have 3 vertices. B doesn't sum up to 180.
Might be a flat earther, dude. Well, let him continue.
Okay.
Yeah, so most globe earthers get that wrong. So yeah, you got it right, which you should, right? It's a very obvious question. But yep, well done on the triangle test. You passed. Very rare for a globe earther.
Can you measure angle on the curved surface?
Get in there, Sasha.
You can it's a tricky question, but you would have to almost use
it's not a tricky question. Look what I posted.
What's it called?
It's not called anything. It's called imagination.
Can you measure the angles on the flat surface?
Well, basically, you wouldn't do it like that, like in that image. You would.
I'm asking you two questions. One is with the flat, and one is
the tangent line, and then measure from the tangent line versus the.
You would use a sextant the way I posted it. You would use it that way. That's how you use a sextant. This is from a book.
Like, I mean, to be fair, what I'm saying would actually argue more to the left. But if I had to like do it like a globe, do I have like a notes sketch app or something? They call me Picasso. No, I'm just kidding. Play Store. I'm getting a sketch app, guys. Watch me. You know, where's Fusion 360 when you need it? You know what I mean?
You think you can get this angle from the surface of a ball?
Not exactly, but I'm arguing if I wanted to measure an angle from a ball, you wouldn't really be able to measure like the true horizon. You'd be measuring more.
You can only use the center of said ball to make angles from.
It'd be well, you can not necessarily.
Yes, necessarily.
All you need is like a tangent point. A tangent.
Know where the center's at.
No, that's where calculus comes in. You can figure out a tangent without the center.
Oh, failure!
You don't think
fail. You're going to fail soon. We're doing good, and now you're starting to go down a failure road. According to you, I can get an angle like that picture I posted. According to you, I should be able to be in that little boat and get an angle to the star off the surface of a ball. There's no way. That's impossible, dude. Put a basketball in your room, put a protractor on it, and get me an angle to your light.
If I may add quickly to my dude who said you don't need a center point, you absolutely do, because otherwise you can't define the function to which you're actually taking a tangent to. If you don't have the center point, that's fine, but then you would need a function, in which case you can actually reverse engineer where the center point is. So if you have either of them,
that's sorry, that's what I'm saying. Like you can almost like infer where the center point is of any curve.
You don't, but the problem is you don't have either. Because I mean, if you think about it, the function of a circle has the radius in it, right? R squared is equal to x squared plus y squared, or r is equal to the square root of r squared plus y squared. It's in there. So if you don't have it, you don't have either. In which case, you can't take a tangent to it. Period.
I'm looking at all these images.
Plus, tangents are just where straight lines meet curves. They're not angles. Angles are two straight lines.
Exactly. It doesn't even have the first prerequisite. That was the point.
That's why you would take a tangent. You would make a line from a plane where you're standing on Earth.
You don't understand. If you don't have a function representing the Earth, you can't take a tangent line because you have to derive from the function. But in order to get the function, you have to have the radius. If you don't have the radius, you can't do it.
In celestial navigation, both the observer and the GP of the star are on the same baseline on the surface of the Earth. There's no tangents. It's two straight lines meeting in a vertex. So we're not going to beg the question of any curves.
Okay, so here's an idea, right? Right now, let's ignore like, oh, I'm able to go like 15 miles out in like infrared radius. Right? Let's just say you can't. I don't know if you can or can't not, but let's just say you can. If I were to like take my like really flat plane like right in front of me, like my flat floor, I could infer basically a zero radius, make a tangent plane to that, and then take an angle. And that math still works out, curve or no curve.
No, but
the point is that the tangent plane I'm applying to what I'm assuming is a curve.
No. Why would you assume it's curved? Why would you assume it's curved?
Well, now that's why I'm asserting it. I'm just, let's just assume it's curved for the sake of thought experiment.
No.
It's not allowed. You're just not allowed to like make assumptions now.
If you do, you end up going down rabbit holes that might not have any meaning. And you're also misusing the term, dude. If you're taking a tangent to a flat plane, that's not a tangent. It's a parallel plane.
Well, for example, in two-dimensional, it would be a line is tangent to a circle. In three dimensions, you can have a line or a plane tangent to a sphere.
Right. Yeah, but you didn't say that. You just said assume the plane is flat and then take a tangent to it. It's not a tangent. It's a parallel plane to a plane. In which case, I'm
losing. You gotta say that again.
Take a piece of paper, put it on your table. Okay? If your table's flat, your piece of paper is your quote-unquote tangent, but it's not actually a tangent because the piece of paper is touching the table at all points. The definition of a tangent is where exactly. And it's intersecting at all points. That's not a tangent.
I get that. What I'm saying is that basically, if I take that piece of paper, I take 2 points on the edges of it to infer a radius, the calculation would basically extrapolate out to if I assumed it was on top of a sphere, that the sphere is of infinite radius. And that's because it's just an imprecise measurement. Yeah, because what I'm saying is that virtually that measurement would say that the elevation is basically none, right? If I take it'd have to be 3 points. I'm sorry, 3 points. The elevation difference is basically none. And so that would equal a sphere of infinite radius, right?
No.
You don't see the math there.
No, I don't see the math at all. Why don't we just do this in reality? So everybody's taking elevation angles from the surface. They're thousands of miles, where the GP and the people taking the measurements are at both ends of that particular baseline. It's a flat Earth, dude. You don't get to infer. You don't get to beg the question of a sphere when people are measuring the Earth flat with angles.
Sphere. There is a reason. Essentially, I'm humoring both models and seeing where the math takes me. That's all. It's just
there's no flat Earth model. I don't know what you're talking about models for. There's no models.
Well, like
the measurement.
I just assume like a Euclidean plane. That's all.
The measurements just take you to a flat Earth.
Yeah, so flat Earth then.
Like there are lots of different flat Earth sort of paradigms, right? Like there's the disk one.
There's one. It's flat. It's just flat.
So flat, yeah, flat.
That's fine. Relatively, the math is all going to be very similar, juxtaposed to the sphere math. If you imagine a person standing on a sphere,
you won't be measuring angles from a curved surface.
You wouldn't. Yeah, no, you would. That's why I mentioned the tangent plane. You would measure it from the tangent plane.
No, we kind of disagreed with your tangent plane. It's parallel. Around in a circle again, dude. Yeah, an infinite radius circle again. That's an oxymoron. Not going to be doing that with a radius of a shape of infinite. You have no defined boundaries. I'm not going to go around in a circle.
I'm not saying that that's realistically. I'm just arguing that if I were to do the math,
that's fine.
Right now, this is the math you could do within like 5 seconds.
Yeah, but we're talking about
the answer you would get.
Is a flat plane. Because the measurement is taken from a flat plane.
Right. That's what I'm saying.
Yeah, it's flat then because it's measured that way.
Right, but I'm saying that because I'm like, oh, this is something you could do like now. Like, oh, I could be like, I'm going to measure it right now. I'm going to grab a piece of paper, do some measurements, and that would be the result you get. I'm not saying
that for me. Do that for me. Measure.
Reality. It's just a.
Do that for me. Take that measurement. Show me what you're talking about.
Yeah, hold on. Man. Maybe let's just do ABC. You like ABC for variable names?
Just draw it out.
Yeah. That's what I'm doing. Yeah, this is beautiful, guys. I'm drawing on my phone. It kind of just looks like a vagina. I gotta be honest. I wish I had Fusion 360 booted up. That'd be goated. I should use color. All right, here's my beautiful drawing. Whoa. Oh, I can't. Wait, am I censored? I can't put an image. All right, I guess I'm censored.
DM it to somebody. DM it to me.
Who knew?
Oh wait, guys, no, wait. It's top of the hour. I'm missing a meeting right now. I gotta go be an adult. All right, sorry guys, I'm out of here.
Bye.